So far in this unit, we've been learning how to use the mouse and keyboard as input devices, triggering our code to run. We can also use external sensors as triggers, such as temperature probes, tilt switches, or proximity sensors. In this lesson, we're going to be learning how to use a range of sensors included as part of the Lego Wedo kit. Let's get started by plugging our USB controller into our computer and connecting our two sensors. The first is a proximity sensor for sensing how close an object is, and the second is a tilt switch that generates different values when tilted. To access programming blocks linked to the Lego Wedo sensors, we click More Blocks and select Lego Wedo. The first few blocks are to do with controlling the motor. Since this is an output device, we will cover this in a later lesson. For the time being, we're interested in these two triggers here. The first triggered by the proximity sensor, and the second by the tilt switch. Let's take the scenario where we want to create a guard dog program that will automatically bark if someone comes too close. All we have to do is drag and drop the when distance block and drop it into place. Then add the play sound block from the sound menu. Let's have a closer look at the when distance block. Changing this value will alter the proximity or closeness at which the code will run. At the moment, anything less than 20 will cause the dog to bark. The proximity sensor provides values between 0 and 100, with 100 being a long way away and 0 being very close. The second setting we can change is the less than or greater than symbol. By changing this to greater than, any value that is over 20 will cause the dog to bark. Since 0 is close and 100 is far away, I'll leave this on less than, so the dog barks when someone approaches. Let's test it out. As you can see, nothing is happening, but as I move my hand closer to the sensor, the dog eventually starts to bark. Now let's take a look at the tilt switch sensor. This provides one of 5 values, depending upon the direction the sensor is pointing in. When it's flat, the value is 0. Tilt it down, it generates 1. Tilt it right, it generates a 2. Tilt it up, it generates 3. And tilt it left, and it generates a 4. Let's use these triggers to create a very simple program that allows us to move our cat sprite using the sensor as the trigger. We'll start by dragging a when tilt event trigger into our programming area, and then adding a change X blocks from the motion menu. When the sensor's pointing right, a value of 2 will be generated, so we'll set our tilt value to 2. Let's now duplicate this code and adapt it to move the sprite left. We'll need to set our tilt value to 4, since this is generated when the switch is pointing left, and change our X value to -10, so it actually moves left 10 spaces rather than right. Let's test these pieces of code. As you can see, as I change the direction of the switch, the cat moves. I'll now add the remaining blocks of code so I can make my cat move in all directions. Clearly these are very simple examples, but as you can see, by using external sensors we were able to make our programs react to real-life conditions. As well as opening up exciting opportunities for different ways of controlling games, this also makes it possible for people with severe physical disabilities to control a computer.